Hi, everybody. Thanks so much for joining us today for our live stream session. We have for your viewing pleasure Mr. Dick Beard, 52-year veteran of the cable industry and a legend in our business. Please join along as he explains a little bit about the history of cable, where it came from, some of the technology, and where it's headed, and offers some great insights about his perspective on the past, present, and future.
Been given probably for about the last 20 years. A little history on myself. I started in cable 52 years ago, so probably longer ago than most of you were alive. But and I was in it from the beginning. So what my course is going to do, or what we're going to talk about, cable systems at a very, very basic level. I don't get into formulas. I don't get into numbers. I don't get into math. I basically speak. I'll be talking about the history of cable, and as things develop, then I'll talk to you a little bit about each one of the technologies. And any questions, just bring them up, because this is the most formal I've ever been. Usually I do this off the cuff with a blackboard and draw things as we talk about them, but we're live streaming, and welcome to all you that are out there on the net. And so I had to get a little more formal, which backfired on us. So we're going to be a little rudimentary here as far as getting our parts up. But I started in cable 52 years ago. My first system was 6 channels. We sold it for $4.95 a month. We had 98% penetration because there was no TV in the town I grew up in without cable. And basically what we did was we had a really tall antenna. It was about 80 miles north of here, and we picked up St. Louis stations. Second system I worked in Quincy, Illinois, we had a large tower in Louisiana, Missouri. We picked it up and we microwaved it up to Quincy, Hannibal, Quincy, Hamilton, Carthage, places like that. And the big drawback then was the St. Louis stations. So you had your local broadcast stations, but with St. Louis, you got PBS, so that was Sesame Street. You got channel 11, which was wrestling in the morning, and you got the baseball with the Cardinals. And back in those days, you would go to little old ladies' houses, and they would have pictures on the piano of their grandkids and the wrestlers from Wrestlers at the Chase. If anybody remembers that, that was their heroes because that was what they got to see all the time. So in the very beginning, basically a cable system with coax amplifiers, passive head-end power supplies. We're going to talk about each of them very, very basic. But what I'm going to give you is just kind of 35,000-foot view of things. But I hope that you leave here with a better understanding about if you're new to the industry, you're going to leave here with a good understanding about basically how it works in a very broad sense. And then as you're taught all the piece parts and the math and everything, it all kind of fits together. Coax cable, to me, is the workhorse of any cable system at this point. If any fiber to the fiber coax combination systems, HFC in that, I would venture to say that 52 years ago, I put fiber drops in these cable coaxial drops in the ground. Some of them are still there working. And so that's 52 years. And that original coax had 6 channels on it. And now everything that fiber is delivering, that coax, some of those coax drops are probably still using this. You know, like I said, it has been around forever. And at this point, while they didn't realize it at the time, you know, with all the capabilities that fiber has and all the wonderful things as far as the bandwidth in that, at this point, so far they've been able to put everything through those coaxial systems, you know, that's coming off the fiber. My first job with cable, just to talk about a little bit about back how things were back then. I couldn't find a job in 1972. And the neighbor across the street was the chief tech of my cable system. So I asked him for summer work, and I got a job at a 320 trailer park that they had a trenching machine, but they didn't have a boring machine. So basically I dug as far under each pad as I could from each side and then drove a 3/4 inch pipe underneath it with a sledgehammer. And that was the conduit that we used to get under each of the cable systems, 320 of them in the summer. And never left the industry. You'll find, and I'll talk about it as I go along, this industry not only has tremendous potential, and it's getting more all the time as we get into what the future is going to hold. You couldn't have picked a better place to get into it. I've always said this is one of the few industries anymore that you can get into it without a college education. And if you use a little common sense and you get along with people, they'll train you everything you need to know. And I have no college. Most of the people that I work with at medium and high level management, a lot of them, the old timers, don't have college, but you can still work up to management levels in this industry without college, just based on what you're doing, in the field and working your way up. And you'll come to a crossroads where you got to decide, would I want to go management or do I want to stay out in the field? And that's a pretty big decision, but each one of you have to make it, and there are tremendous opportunities in both of them. So basically, you all know what coax cable is. It's basically, and when you look at the end of it, you're basically seeing your outer conductor and your braid, you're seeing your dielectric, and you're seeing your center conductor. The important thing here is that always remains perfectly the same. We used to use staple guns a lot in our industry, but the staple gun would indent the cable a little bit. Any change from that perfect circular, that perfect distance between here, will change the aspects of that cable. You might not see it, immediately, but over time, as it compounds itself, you're going to see problems. And basically, it's an outer conductor. It's usually something that's waterproof. Sometimes it's pretty heavy duty. And then you've got a wire braid in there. And that wire braid is two things. It's the grounding, but it also sets up a different potential between the center conductor and the braid. The dielectric, through the years, it's been made out of a lot of different things, but it basically sets up the like I said, the ratio between the center conductor and this that allows the cable to go as far as it does. Center conductors used to be made out of pure copper, not a long time ago, not anymore. When you're working with center conductors, you're always going to have a little residue on there, and that you have to get that off. What you have to remember is that is now only a very thin copper layer that's on that center conductor. It's not pure copper. That thin copper layer on the outside is where everything happens. So if you're using a knife to scrape it, you're using any kind of metal or anything to scrape it, and you scrape that metal off, you're impeding the ability of that cable to do what it's going to do. So as you think about this, you're always tempted to use knives or something. If you don't have your stripping tool on that, don't do it. You've got to keep that intact. With the cable, and we'll get into this as we go along, but three things affect the loss. So the size of the cable. So you've got everything from 1 inch and 3/4 inch, as you can see up on the board, the heavy aluminum shielded coaxial cables, all the way down to cables this size, and then the head end, you got mini cables, which are much smaller. So it's the size of it. The bigger it is, the less the loss. That's the easiest way to remember it. The bigger the cable, the less the loss. And then how far you go is always going to affect it. And and then the temperature. So this cable at 100 degrees outside loses a whole lot more than it does at 0 degrees outside. So if you stop and think about that, you got miles and miles and miles of coax out in the field. And when you go from summer to winter, there's a tremendous change in that to where you're getting higher signals or lower signals all the time, and you're going to have to compensate for that as we get along. The only other thing I mentioned, and I apologize for the drawing, I'm sure you've all seen them. When you're out on the poles and that, you see the expansion loops in the aluminum cable. So it's always, there's always, some people call them drip loops. I was looking on the board, but they don't have any up there. But I know you've seen them. It's just a big U-shaped dip in it. And the reason that that's there, and the reason that that is critical, is that that's aluminum. Aluminum contracts and expands with temperature a lot. So what that does is that allows that cable to expand and contract without breaking or cracking or putting too much stress on the cable itself. And the reason that's important is because if you get a crack, you get any kind of an issue in the cable as far as the integrity of that outer shield, you start getting interference in that into the system. So the expansion loops, if you're replacing taps down the way and that type of thing, you've got to make sure that you put those things in correctly. It's not just bending it by hand and making it look like the one that was there. You know, there are methods and tools that you have to use to keep that integrity. Can you give me that next one there, Pete? In the cable system, you're basically you're going to leave the head in. We'll talk about it in just a second, but I'm just going to talk about the different parts first. So the amplifiers, there's actually three different pieces to the amplifiers, which are the large boxes that are on the wall there. And that is a forward amp, which is, if you think about it, going from the head end to the house, that's your forward path. And so between here and the head end, you're going to have splitters, you're going to have different pieces of equipment, you're going to have your cable loss and everything. The whole reason and that the cable system works the way it does is that leaving each amplifier, you have to have exactly the same thing. So that's the whole aspect of design. Everything else is based on the premonition that everything coming out of this right here is exactly what it was at the one before it, and the one before it, and the one after it. And that's how you can design this, because you know that that's your base point. What that means is that if you've got 1,000 feet of cable, if you've got 600 feet of cable, if you've got 8 different pieces of equipment, if you've got no pieces of equipment, there's going to be different losses between those amplifiers. And you have what's called unity gain. What unity gain means is that this forward amplifier has to completely compensate for all the loss that was in that cable as it came in. So when we design a system, when you're thinking about troubleshooting and that, and I'll have some diagrams here in a second that will show a little bit more about it. You also have the return system. So you have a signal going from the head end out to the homes. You have a signal going from the home back to the head end. If you think about it, it used to be ordering video games. So, you know, you would say, I want this game, I want this movie, I want whatever. So you would send a short burst of I want, and then you would get a huge burst of a movie or a game or something coming down to you. So there was very little going on the return, a ton coming back on the forward. So the return system is the same cable system that's out there. They're both the same cables and everything else. You just got systems, you got signals going both ways. And we'll talk about how they do that. Then each one of these amplifiers, if you've got what you call your feeder, your distribution system and that, you've got another amplifier which expand, you know, which blows the signal up even more, increases it even more. And that's the system that goes out to all your homes. So every piece that you put into the system causes loss. Loss is your enemy. The farther you go, you hit a certain point, you're going to have to amplify it back up. Problem is, every time you amplify it, you throw interference into it, and that interference accumulates. So what you have to be careful is there's going to be a limit to how far you can go before the interference gets to the point that you can notice it, or it interferes with your signal and shuts you down. And then there's a smaller line extenders that you're going to hear about that it's just simply in the feeder system in the homes. And that's just another amplifier that just has a forward and return path on it. Again, we apologize for how the presentation goes. We don't have a tripod, so we're having to put everything up individually. So you got your amplifiers, you got your coax. The next thing you have is your passives. Your passives are going to be either how you're splitting your mainline cables. So you're thinking about, you come down a street, you got to go to 2 different streets, you got a splitter. Basically, all the splitter does is it comes in with coax. You have them in your homes, you have them out on the main line, you have them on distribution, you have them everywhere. And it's basically just going to split your signal. And it's a flat loss, and it basically divides your signal in half, which when you start talking about dB, it's going to be 3.5. I think it's still 3.5 dB per per leg. So the splitter is how you're able to split your signal down different paths. A directional coupler is basically a splitter, but what it does it a little bit different. So instead of splitting it equally, your directional couplers allow you to maintain most of your signal going through, and then it's like a tap where the off leg that you're going to go down another street. Let's say you're right out of an amplifier, you got tons and tons of signal. And you've only got 2 taps going down the side street, so you don't need a whole lot of signal down that street. If you use the splitter, you're sacrificing all that signal going down the through loss, the through side, instead of going to the 3 homes. What the directional coupler allows you to do is it allows you to send most of your signal on down the system so that you can get maximum distance before your next amplifier. And it allows you just to tap off a very small amount of signal and send it down. So some of these will have what they call like a DC 16, directional coupler 16. Instead of being 3.5 dB of loss on that leg, it's going to have 16 dB of loss on that leg. But that allows the majority of that signal to keep on going. And if you have 1 tap, 2 taps or something, you don't need that much signal to go that distance. Taps are very simple. You're going to run into all different levels of taps and everything. You're going to run into 2-port, 4-port, 8-port taps. You're going to run into, again, some of this might be dated, but you have your 8 dB, your 12 dB, your 16, 20 dB taps. Basically, all a tap are these 2 put together. So if you got a 4-port tap, you've basically got a directional coupler in here that goes into a 2-way splitter. Then each leg of that 2-way splitter goes into another 2-way splitter. So you basically end up with 4. So when you're trying to figure out the value of that tap, each one of these is 3.5 dB. That one's 3.5 dB. So there's 7 dB of loss. And then whatever the value of directional coupler is. And that's how they put these taps together. So it's very simple. As far as how that goes. So that's the only other thing. Go ahead, Pete. The only other thing that is on the system, and I'm not going to get too much into it because it gets pretty involved, but is the whole concept of powering. So all these amplifiers and everything have to have power on it, and so the power it's going to be you basically got a power supply. It's taking 120 volts off of Ameren or whoever your power company is, and it's transforming that down into back when I was working, it was 30 volts. So when you wanted to see if you had power, you could just take your finger and stick it across. Don't do that now because you guys use a whole lot more than 30 volts on your system. But it's most of them are 60. I think most of them are 90 now, if I'm not mistaken. They have some 60. Most of them are 90 volts. So there's 90 volts power, and it's all still riding on that same coax cable. So you've got your forward signal, you got your return signal, and you got your power all on the same cable. And basically what that does then is you have power supplies, and I've got some diagrams later that kind of show them, but the power supplies basically transform 120 to 90, put that out on the system, and that's what powers all your amplifiers and line extenders. So when you start talking about the cable system, the forward direction, you're coming out of your head end, you're hitting your amplifiers, power supplies. The nice thing about the power supplies is that they can power either way on the cable. So they don't care if it's forward, reverse, or whatever. So that allows you to put your power supply in the center of a run, and you can power both ways, so that you're going half the distance that you would otherwise to power both ways. So basically the way the system's set up is you got your amplifiers, you come into a splitter, and then you come out, here's your distribution to your homes, here's your line extender. Now, I've always taught this, and some people say it's getting a little dated, but I equate this whole thing to the water department and the water system. So you got your water flow that's coming out of here, and basically, as you're coming out, you're basically just dividing your water lines, and as your water flows, you're getting less and less and less. So each one of these is kind of like a pump station, and this make more sense here in just a second. But as you're coming out, let's say that you've got something getting into your water system over here, it doesn't affect any of this, so any problem that you have on the cable system typically only affects what's downstream from it, so if this amp goes out, you lose everything. But if this amp goes out, you just lose this right here, okay? Any interference that gets into this, any outside interference, any interference from a bad piece of equipment or anything, only affects that downstream side. So it makes it very easy to troubleshoot that on the forward side, because you just got to find where you've got something good. Then after that, then you start isolating things down. Your taps in that. The interesting thing is, go ahead, bring this in. So the reason I say that is because when you, and the reason the water makes a little bit of sense. Is this is what the reverse looks like. So now on your reverse, what you're looking at is you don't originate from the head end going this way, you originate in the house coming back this way. All right. So now if you think about the water, if I get a problem up here, that problem affects everybody because it ends up down here. And not only does it affect everybody, because it's, it's going all the way back to the head end and then coming back out, but it's additive, so when you have, if you got like some interference in the system and it's in a couple different places on the forward, it's in different legs and it's dividing. Here, any problem that you end up with, whether it's somebody's got something running in their home that's got bad electrical contacts and it throws interference into the system or whatever, it's additive. So everything is coming out of this house and this house and this house and this house. It's all adding together. And so on your return path, it makes it much more difficult and it makes it much more critical to to maintain a tight plant where you're not getting any outside interference in, and it makes sure that everything in the homes are tight. If you got a loose connector or anything like that, or an old splitter that is not sealed properly electronically, and that anything that would allow the fluorescent light interference to get in, just the noise from refrigerator motors and the electric lights and the electric drills and hair dryers and all that type of thing. These systems got to be tight because it is an additive effect on the return that everybody that's hooked up to your cable system, all that return path is just like water. It's growing and growing and growing, and any problem that's in that grows and grows and grows with it. So the return path, when we went to the return path, it got very, very critical, both to have a tight plant and to maintain that plant. So back up just a little bit and talk about kind of the history of how we got to where we are today. So as I said, we started out with a 6-channel system. I started out 6-channel system, and at that time, back in the mid 70s, and that there was no cable in St. Louis or Boston or Chicago or any town that had, because all that was out there were broadcast signals. You didn't have movie channels and ESPN and all this. There were no satellites. There was no earth stations. You basically had what you picked up off the air, or with cable, you could put up a really tall antenna, or by using microwave, you could bring in St. Louis stations for, just your opportunities for wrestling, Cardinals, that type of thing. I worked in a system in Lincoln, Illinois. I built that system. The interesting thing about Lincoln, Illinois was back in the day, this is back in 74, 75, 76, there was a company called United Video. United Video out of Chicago had these microwave networks that came all through Illinois and Indiana and in areas. And one of the things that they carried on those microwave networks was WGN. So when you talk about superstations, WGN is one of your superstations. The reason for that is that anybody that was along the path of those microwaves could tap into that, and all of a sudden they got Chicago stations, and more importantly, don't kill me, the Chicago Cubs, which is my favorite team. So so everybody, that's how the Chicago Cubs got so widespread, is that people 300 miles away could still pick them up because of these microwave towers. So people were always looking, how do I get a new service? How do I increase the value by adding something that they don't have? I worked at a company called Continental Cable. Before there were any movie channels or anything, we had 3 big tape deck machines, and we had our own movie service. And I was in Quincy, Illinois, a little small airport. Every morning you'd run out to the airport and ship the movie that you showed the night before out and pick up the movie for the next night. And we had to deal with Hollywood theater, the producers, that we were getting semi first run movies. It was a service called Cineview, and we would hire college kids to sit there and run those movies at night. And then we had to immediately ship them to the next system and pick up ours for that night. So if there was a plane problem or something, you showed the same movies 2 nights in a row. You know, but it was very, very rudimentary the way we did it. But you could sell that for an extra, $1.95, $2.50, and make a little bit more money on what you're getting. And they're getting, so that was kind of, and a lot of companies were doing that. That was the first, paid movie channels that were out there, were basically shuttling through the mail or through the airports or whatever, shuttling movie tapes from place to place, and then showing those in your systems. So in about, I would say, in the mid to late 70s, they started launching the satellites, and you got into the age of earth stations. You cannot imagine what it was like when you first got the earth stations out there. You never dealt with it before. Basically, you've got satellites sitting up at approximately 22,600 miles, which keeps them in a stationary orbit. So they always stay in the same place. They rotate at exactly the rotation of the Earth. They're all on the equator. And so all your Earth stations, that's why they never have to move. They're pointed at a satellite that is rotating exactly at the same orbit that the Earth is.
That is
Geosynchronous. Yeah, geosynchronous orbit means that they never move. So there's approximately 7,000 satellites up in the world, up in the space today. About, I think, somewhere around 500 to 600 of them are in this geosynchronous orbit, and they are spaced 45 miles apart, all the way around the equator. And now in the early days there wasn't that many of them up there. So when they started launching HBO and Cinemax and all the different channels, everybody wanted to get up on these satellites. But there was a limited number of transponders, which is basically the transmitter on the satellite. I think they used to have 26 on each satellite. So you would rent a transponder, and sometimes you had like a 6-hour service or a 12-hour service. So they would actually put more services than one on these transponders based on the time of day that you needed it. The other thing is that an HBO would have a first right of refusal. So if an HBO transponder went down, they had paid that they could go over here and kick you off your transponder and take over your transponder. So, back then it was brutal, and you would have a service up there and all of a sudden you wouldn't. Funny stories about that. When we were first putting up these earth stations are 5 meters back then, and they didn't have, now you guys have the big, I forget what they call them, but it's the ones that pick up a lot of different satellites. You have one big, huge earth station, and it's pointed at all different satellites. Back then, every satellite had an earth station. These things are 5 meters wide. And when we put our first one in up in Quincy, Illinois, you got it, and then you had to sight it in. And so basically you kind of had the compass heading that you needed, and then you had the angle that you needed. And this thing's 22,000 miles ahead of you, and you're trying to zero this thing in like with a rifle scope, trying to get it up there. So we got it to the right compass heading. And the first one, we thought, well, they got to be somehow counterbalanced, because it says that you just lift it, and that's, we had 2 guys holding it, and we cut loose the bolt, and I mean, that thing must have weighed 600 pounds. And there was no counterbalance. So we were gradually sinking, and we said, tighten it up, tighten it up. We tightened it up right on the satellite. We thought, this is easier than we thought it was going to be. It took us 4.5 hours to get the next one sighted in, because it was just pure luck. The other thing that was funny about it, and think about the satellites too. I go to Alaska every year for a trip. These are all on the equator, and because of the curvature of the Earth, and the farther away you get, the signal reduces. So when you get up into Alaska and northern Canada, and that, you go from 5-meter stations to 10-meter earth stations. These things are huge. And the other thing is that if you stop and think about it, the farther away from the equator you are, you're right on the equator, you're pointed straight up. When you get up into northern Canada and Alaska, these earth stations look like they're pointed at the ground. so that because they're pointed just above the horizon so that they can hit that satellite, down there. So depending on what part of the world you're in is going to depend on how up or down your satellites are. The other funny story I'll tell you is I built Belleville, Illinois. What I left out of my history is for all of you that work here in St. Louis. In 1977, I came to St. Louis and I was part of the franchising group before there was cable here. So probably about 25% of the cable systems in St. Louis, I was part of the group that built them originally, not what they are now, but originally. At that time, there were 8 different companies serving St. Louis, different parts of it. So I might have Jennings and somebody else might have Singing. Somebody else has U-City, somebody else has Clayton. And over the course of time, just because the economics were there, they just kept combining and combining until you end up with Spectrum pretty much serving all the St. Louis market. And so when we built Belleville, we were in an old bowling alley downtown was where our head end and our office was. And all this is gone now. But when we activated our satellites and we had it on for about 2 weeks, everybody's getting it. This lady calls up and she says, your religious channel is showing porn at night. And we said, well, that's not possible. She said, no, she said, it's got, we got religion during the day, but I turned it on the other day and it's got porn at night. And so we watched it and we were on the wrong transponder in the wrong religious service. And it was a 12-hour service. And then for 8 hours, they had some porn channel out in New York came on and used the transponder. So it just popped up. Well, so we immediately switched it, got it on the right one. The next day we got called from 3 firehouses in Belleville wanting to know where their evening's entertainment went. Because they were sitting there every night. They were sitting there every night watching this and they thought, this is great. So but that's the kind of stuff that went on, back then that you don't even think about or worry about today. But I tell you, much like my presentation day, it was a lot of trial and error. You learned by doing it, and then if you saw a better way to do it, then you did it that way the next time. I tell the story. We didn't have bucket trucks. We didn't have pole setting because we used all the power company and telephone companies' poles. But you had the drop poles that you had to put in the backyard sometimes, or the intermediate poles. We used to set those with post hole diggers. We dig the hole, and then you dig out a slant on one side of that hole, and you put the butt of the pole in there. These are small. By the time they go up, they're probably 20-foot poles, about 6 inches, 8 inches across. They're not that heavy. And you would have a guy sit on the hood of a truck and have a guy sit on the roof of the truck. And you would hold that pole and start driving that truck slowly forward. And those 2 guys are pushing that pole as it goes up, and they got to keep pushing it. They can't, or it's going to fall on them until it drops down into the hole. That's how we used to set our sub poles back then. So there's just a lot of stories. We were out one time in a blizzard, probably about 10 degrees below zero, a friend of mine and I, and we were up there and we had to take this connector out. I said that aluminum contracts and expands with the cold. When we popped that connector off that amp, that cable shot back 3 inches. So now our cable's 3 inches from the amplifier that we got to get it back in. And it's not a drip loop or anything. It just shot back. So some of the things you saw were amazing. When I first started, all of our amplifiers were tubes. So if you've ever seen old movies of a TV repairman, it's got this little box that he carries around, and he puts these glass tubes in to use it. So an amplifier housing that was up there, you'd have one for the trunk, one for the feeder. They were as big as this right here, and an amplifier was half the size of this. And these things put out some heat. So they're sitting up there. So if you're up there in the rain or you're up there in the snow, you had to get totally covered up underneath there, because if water hit one of these tubes, it blew up, and you were like a TV repairman. You were up there, you took up this little box of tubes, and you took out this tube, and you just kept replacing tubes till you found one that fixed your problem. Now we've got, everything's semiconductors and transistors and chips and all that. So you don't have any of that. But So, so to get back to the reverse, the other thing that we're going to talk about, but is in a little bit, but the thing about that has changed in the industry as it has come about is that there's been more and more and more traffic. Why don't you bring my next one there? And so there are the limitations that you have in your system. You could only go so far with your system. Because in before digital, you have what's called analog. And analog, basically, as your signal degraded, you got a little bit of snow and more snow and more snow. And, some people with bad eyesight, man, you could get away with a lot because they couldn't tell what was their eyes and what was the TV. So bad signal on that, didn't worry about them. Other people, you were out there all the time trying to get it as clear a picture. When high def television came out, it killed us because every little piece of anything showed up. And as I said, amplifiers add interference, line extenders add interference. There's just interference that's coming along. And that interference level would be rising. When you stop and think about coming out of these amplifiers, it's the same level all the time. But that noise level or interference level is rising. And at some point, it gets to the point where the human eye can see it. And at that point, you start seeing snow or degraded pictures. One of the greatest things that came about was when everything went digital. So digital, instead of having broadcasting the picture itself, you're streaming it. Basically, you're streaming it on your service as well. It's all ones and zeros. It's all dots and dashes. And what that did was it took the place of your eyes. So that noise is still a problem, and all that interference is still a problem. But now with digital, it gives you the same picture until it reaches its line, and then it shuts off. And what it'll do is you'll start seeing that tiling. I don't know if you've ever seen in a movie or a picture or something, you start seeing those little tiles that kind of freezes, and that means that you're getting close to the cutoff. But with digital, it's either on or it's off. And so for the video side, it makes it pretty simple. That as long as you maintain your signal level and that where it needs to be, you're going to have a good picture, and everybody's going to have the same picture. Instead of a little bit of noise here, a little bit, a little less noise there, and that. But what happens is because each one of these amplifiers is adding interference in, and you're getting just some of the built-in interference from the systems, there was a limit of how far you could go. Because even if everything was working right, each amplifier is adding a little bit of interference in there. So as that adds up, you might get to 17 amps, you might get to 20 amps deep. Some people went farther than that, to where you can't go any farther, because that's the limit from the head end of how far you can go before your signal degrades to the point that you can't use it anymore and it doesn't work. So it's so that was really the first impetus for fiber. So the first use of fiber was to minimize the length of your runs, because with the fiber node, basically what happens is instead of the coax, the fiber, and we're going to talk at the end just a little bit about fiber theory, but not much. But the fiber is basically a tiny piece of glass, but it's actually two pieces of glass. There's an outer glass and an inner glass. And what happens is it sets up a mirror effect. So where those two pieces of glass hit, it's a mirror. And so when you shoot a laser signal down there or a light signal down there, it bounces. And it just keeps bouncing with almost zero loss, as long as you maintain the integrity of it. And it's really funny because if you stop and think about it, you're running down and it's, and we'll talk about this a little bit more later, but you're running down this cable and it's just bouncing. But you have to be careful with fiber, because if you turn it too much, what happens is it's running along there, and instead of bouncing, it doesn't hit the right angle, and it's gone. It's almost like it just shoots out the end. You will cause it to not have that mirror effect well enough that you lose your signal. So you have to be careful with fiber on your bending and that type of thing. But But again, the beauty of fiber is you take from the head end and you run this fiber out, and then you put in what's called a fiber node. Basically, a fiber node takes the light signal, converts it back to the coax signal or the RF signal that you were using in your coax. Okay. So, but at that point, it's the same signal as came out of the head end. It's like a brand new head end, only you don't have all the, the earth stations, antennas, and all that. So this was a huge breakthrough, because now what you could do, when you stop thinking about it, is if 17 was as far as you could go and you couldn't go any farther, now you could take this out and, I show it with 6, but basically you could take this out and you can go farther. But at this point, your number 7 amp here now becomes your first amp in cascade, and second, third, and fourth. So, and you can just keep doing this over and over, and you could have, if you had a 36 amp cascade, you could drop one of these nodes in and then run another fiber on past and drop another node in, and you can go from 36 amps down to 12, down to 6, whatever cascade length you wanted. And the other thing they quickly realized was, not only could you put it and just feed on out, but if you ran it on past that and reversed your amplifiers on the input side, you could run 6 amps each way. So you come out of the node, put a coupler, and instead of going 12 amps, put it in the center and just turn your amps around so you're feeding the opposite direction from the node instead of the head end. You could get 6 amps on each side, and you just have your amp cascade in half again. And so again, the whole reason for fiber in the beginning was simply to be able to expand it was to improve your outer limits of your system, but it also allowed you to expand your system farther than you could before. You might have reached your limit and that was it. And there might be some subdivisions, there might be town, there might be other things on out there that you want to get, and you couldn't because you were at the limit of your cascades. And the only bad thing is that the powers that be back in those days, you put this here and you had 8, 10, 12 amps going each way, and they thought, well, shoot, that's so good. If we put more nodes in, then we could improve the signal even more. So these 12 amp cascades, now all of a sudden they want to break those down to 6. So they put another node here and another node there. You're constantly switching the amplifiers around. They might be forward this month, and then a year later they do it to the 12 amp cascades. So 6 of those get turned around the other way, but then they split that one in half. So 3 of those get turned around the other way again. And that was, when we talk about upgrades, that's what upgrades was, the coax stayed the same. The amplifiers and all that stayed the same. It was just changing the direction as you put these fiber cables in. Any questions? So like I said, just bring up questions as we go. And the other thing is too, again, this is usually much more off the cuff than this. And so the other thing I always tell you is that as we're going through this, especially for new folks, if there's anything you've heard, like just in day-to-day conversation around the office, terms or anything like that, bring those up too, because that's, a lot of times you'll hear people talking, you're wondering what the heck is that? What is, there's different interferences or different problems that they had or different issues that they ran into. As I said, it is a very interesting industry. 52 years, and I don't know that much about the new part of it, only because I got at a certain age, I got to the point I said, I know enough, I don't need to learn anymore. The younger kids can take it. So if something came up, I gave it to them. It's a funny story, and some of these guys have heard it before, but being in this industry, I started with no college education. I started out literally digging ditches, and just stayed on and stayed at it. I installed tech, I climbed towers, I did construction. I was on the operator side for 25 years, and then I switched over to the construction side about 26, 27 years ago, and I've been on the construction and building side since then. And now I work for a equipment supplier. But it, you know, and as you go through that, you know, I tell people, I don't know that much. I'm not that smart. I said, I lived a long time. I stayed in the same business and I didn't tick anybody off, you know, and that's the key to my success is that, you know, you get along with people and you learn from people and you work hard. The other thing that, you know, I'm in, I've won awards for engineering and I'm in the Engineering Hall of Fame for the SCTE. And I say it's been a bluff on my part because I don't know squat about engineering. You know, I know basics and technical on that. But I said, I always made sure that I had good people working for me and I let them do their thing. So if you do get into management, that's the key to management. You're never going to know everything that you need to know about whatever you're over, especially if you're in any kind of engineering management or something. There's no way one person's going to know everything about it, but you're going to have people working for you that do. And I always say I am the orchestra leader that never played an instrument, but I know what you play and how to get the best in what you play and what you play. And when you put all together, then you got a good operating cable system, but each person's playing their part. If, you know, thinking ahead and as you go through your careers, just if you can remember, the key to good management is not you knowing it all, but making sure you've got people out there that each know it all about their particular function. And then the important thing is you got to let them do their job, you know, and let them do what they do best and you reap the rewards of it. So it's, what time did we start, Dennis? About actually, we'll go about another 10 minutes and we'll take a real quick break. So, the, why don't you let me see what the next one is. So again, so the fiber, the whole thing about fiber as it came out was, for cascade reduction. Now we start getting into the kind of the meat of it. So back in the, I think of where I was in my career at different points, but you know, during the 80s, they started finding out that not only could cable work with video, but you could also use it with the digital side of it. That you could also do telephone, you know, and you could also do the internet. So you could become a pipeline for internet services. You could sell, you know, as you do now, your triple play or your quad play with your mobile services and that. But back in the very beginning, that started out very slow. And at that point, a lot of systems were trying to figure out, you know, do I do phone or do I do internet? And most of them did internet. Some of them did phone. I worked for a company that actually did phone, tried the phone side. But the thing about the internet is, and the thing about fiber, and when you think about the career that you've taken here, the career path you've taken, there is no better way out there to get the speed and the bandwidth and the capacity you need for the internet than fiber. You know, you've got satellites and you've got copper phone and you got all that, and that's all well and good, but they've all got limits. And it's even the coax has limits, but the SCTE has standards committee that are constantly upgrading kind of the back office software side of it to keep up with what's going on in the fiber world. So everything's going on in the fiber. And this is, you're going to hear DOCSIS 1, DOCSIS 2, DOCSIS, what are we on now? 7 or something, or 5, 4, DOCSIS 4. And basically what that is as the capacity and the capability and the new innovations on the fiber comes out on the coax side, you got to keep up with that by coming up with you know, with the technical ways of making coax mirror that so that you can pass the same thing on it. You know, a lot of people say, well, why don't you just go all fiber to the home? I can tell you that in a system like you're working in and in all the cable systems that are out there, if it's not new build, you know, the labor cost is huge to put in a fiber system. But I can tell you that the majority of the cost is in what they call the last mile. So you can build these cable systems that are out there. You can put fiber in and everything, but where it gets expensive and where the prohibitive cost is from the curb to the home. Because now you're talking about every one of your customers, you're talking about having to rewire their home. And the coax that's out there in the neighborhoods, in that last mile still works, and it works great. And it does everything that the fiber does. So there's no reason to replace it. But if you stop and think about what it would take to take an existing system to fiber, all fiber, it is a monumental task that, both not just in the cost of it, which would be prohibitive, but just think about having to arrange with every single one of your customers to go into their house and rewire it, for fiber instead of for coax. And another interesting anecdote, and I'll just throw it in here. When you get deluged with calls and everything, we did a study one time about people who are calling in, and you think everybody in your system sometimes is upset or because your system's not working. We went through and we took a system. That system had about 20,000 people in it, 20,000 customers, and we looked at how many people call in. And as far as repeat customers, it was like 2%. It was the same people sometimes every week. So it's but as far as people who called in, it was only about, after their initial install, it was only about 20 to 25% of your people ever called in again for service. Now, most of them had problems, but they just, their neighbor called in or it fixed itself, or they just gave it a little bit of time. I had a channel card from an early system that had one of these 6 or 8 channels, and on the back it had tips for the homeowner about what to do, when to call cable, when to call TV man. And they said, if your cable is out, give it some time, because your neighbors are probably out too and they'll call in. If your cable's snowy, they said, check your TV, check your neighbors. And if your neighbors are not snowy, then it's probably your television. That was, I mean, they got away with that somehow, but it's, and so people would be calling their TV man but there would be these call your cable neighbor, they said, call your cable neighbor. If theirs is out, then there's a problem and we'll take care of it. If it's not out, it's probably your TV set, it's, so, but it's, so what happened with the internet, and that is that as you're adding on the internet, and as you're adding on the phone, this is more and more and more bandwidth that you're using in the cable system. What became a real issue with it was when you went from requesting movies and requesting games. Again, like I said, you say, I want a game. And that little blurb went up, and then you got tons of bandwidth coming down with a movie or a game or something that you're downloading, which was great, because on the forward side, you've got bandwidth from like 52 megahertz up to they go to 1 gig now. And most of them are what, 850, 870. So you got 870 megahertz bandwidth. On the return side, we had what was called a subsplit, and you had anywhere from 5 to 50 is what they said, but it was a whole lot less than that. You had probably about 20 to 30 megahertz of bandwidth. So you got 800 going this way, 20, 30 going this way. So when you stop and think, that is a very, very small pipe coming from the homes back to the head end. And again, it's all additive. So everybody that's requesting, all that traffic is adding together on the bandwidth of that coming all the way back in. So you take that last section of the head end, right before the head end, there's a ton of stuff coming in there. Well, then all of a sudden you came in with the interactive games, where you're not just saying, download this game. Now you're talking to people and playing, or you got into things like FaceTime, and you got into all the talking back and forth. And all of a sudden, the amount of traffic that's coming from the homes back to the head end increased exponentially, because now everybody is not just saying, I want this movie. They're putting their own movies, and putting their own short films and putting all their own stuff on the network and sending it out. And, that very quickly became a huge, huge problem, because you started getting delays, you started getting crashes, because it's just too much traffic that's on there for that system to handle. So why don't we take a real quick break right now, and for about, let's say about 5-10 minutes, restroom, donuts back here and that, and then we'll get into kind of, the modern age of the cable TV and where we're at today and how we got to where we are, fiber to the home, fiber to the, node, fiber to the neighborhood, that type of thing. And it's all because of, it's the return path that's creating this whole need. So why don't we take about 5-10 minutes? So as I was saying before the break, as the amount of traffic coming from homes increased, it started filling up the bandwidth, started filling up the bottle to where you started getting delays in this. And it's not just anymore, it's not just people, it's all the piece parts that are in the home. All, you got security systems, and you got refrigerators, you got all kinds of things are on the internet these days. And somebody estimated that it was somewhere between, each house has between 7 and 10 active devices right now talking to the internet, and they expect that to increase to, in the 15 to 20 range at every household. And all this is coming back. So when you think back to my diagram of the return path, that's just all adding up and adding up and adding up. So then we got into a stage of the industry where everybody talked about how big your node size was. If it was your node size 5,000 homes. So, you go from your head end, you place a node, you expand out, you got 5,000 homes in that. But as the increase kept coming, and the increased bandwidth and the increased usage in that, you kept going, and everybody's in a race. So I've got a 5,000 home nodes. That's where I'm at. Well, shoot, I'm at 3,000 homes. And basically all that is increasing the amount of fiber in the nodes. Your coax system stayed exactly the same. The only thing you did once in a while was you turned your amps around the other way. If you place the node and then you place another, you're just constantly turning your amps. But this thing just went, every technical session that you went to, every webinar that you sat in on, it was node size. Node. Now I'm at 1,000 home node. Now I'm at 500 home node. Now, when you stop and think about it, though, you're starting to get an awful lot of fiber and an awful lot of nodes out there. When you start getting down to a 200 home node, that's not a very large area. When you stop and think about the size of St. Louis, and every 200 home section is going to have a node, with fiber running to it. In the early days when we first ran fiber here in St. Louis, a 6-count fiber or a 24-count fiber was the norm, and everybody thought that would always be plenty. Now you're up in the 244s and 488s, you're in the thousands of fibers, per cable that you're putting out there, just because of this constantly increased capacity. And eventually, and Sean, I don't know if you know what your node size is now, because you kind of got to, like, a lot of people got to node plus 0. And what node plus 0 means is, well, you went from node size, then you start talking about, okay, how many actives do I have? Because that's the more important thing. It's not the size. It's how many amplifiers you have on, or how big that node size is. And so then you got into node plus 7, which means you placed a node, and then you had 7 active devices after that in cascade. Now, there might be more devices, but it's the cascade length. So if you stop and think again, you got your first amp, but then you go to a splitter and you split off, and you got an amp on each one. Each one of those is your second amp in cascade. So each time you split, you got one, you got 2 2s because you split it, and over here you might have 2 3s because you split it again. If that makes sense to you, So then you got into node plus 7, node plus 3. Most places these days are down to a node plus 2, node plus 1, or a node plus 0. And a node plus 0 means you've got a totally passive network after your fiber node. There are no coaxial amps. You've got it down to the fact that when you leave the node, you're right into the distribution, the feeder of your system. And, so it was just more and more and more fiber. And you'll be getting into fiber, down the way. Right now you're not going to, I said, you're installing, you're going to be in coax and troubleshooting that and everything. But the interesting thing about the fiber is that really not much goes wrong with it. So by taking the number of amplifiers in the system out or decreasing that, you've made everybody's job so much easier, because it is the amplifiers and the line extenders that are the majority of your issues. What you're going to find when you're troubleshooting these days is I believe probably what you're going to find is that the majority of your problems are going to be that you run into in homes, and that are going to be connectors. And it's going to be the coax. It's going to be either some kind of a problem with the coax, either somebody cut it, squirrel chewed into it, something like that, or you're going to have connector issues. And most of the time those are in the homes. It's where somebody's hooking up their own equipment and that type of stuff. And the meters nowadays and that you're going to learn how to use on your troubleshooting, and that they do 90% of the work for you. They pretty much tell you everything that's there. But I tell you, whenever you have the chance that you can go old school and get back into how it works, people can train you how to fix something, but they can train you just how to treat the symptom, but you don't know how it works. With your car, they can teach you how to maybe change a headlight, but you still don't understand how the car works. And if you get that knowledge, then you're way ahead of the ball game, because then it's not just you doing what somebody told you to do. You can start thinking in the back of your mind, wait a minute, so if this is this, maybe you go from there. You start kind of working. And Dennis and I were just talking, in a fiber to the home system where there is no coax guys like us we got nothing to do, because nothing really goes wrong with fiber. Either the transmitter fails, the fiber breaks, or the receiver fails. That's all there is. There's just those components, and there's nothing really in between. It really cuts down the amount of workmanship. It cuts down the amount of thinking that you have to put into it. But any chance that you get to get just very basic courses, and there's some white papers and things, or there's papers out there, you can get it. Just back to the basics about how this stuff works. It really does wonders to how you think about it, and it makes your career a whole lot more interesting. We're going to talk about careers a little bit more at the end. So that's basically what this is we went from node size to then when the node size got so small, then we started talking about node plus 3, node plus 2, node plus the actives. And any new build that goes out there these days is probably going to be fiber to the home. And you may have read about we're going to talk about a little bit, the huge amounts of money that the federal government's spending to wire all these farmers, in all these rural areas and that. Just talk about careers. This was a great career before COVID. After COVID, this is an amazing career. There are no positives with COVID. I've had it 3 times very badly, believe me. There are no positives with COVID. But if there was, one of the huge positives is what it's done for the internet. Because we used to be, cable TV and broadband and the internet used to be a luxury. You could have it, but you didn't need it. But after COVID, when everything shut down and all these kids started having to do schooling at home, and everybody had to rely on that for their shopping and all that type of thing. In small rural areas I come from, I have a cousin who owns this is still today, I have a cousin who owns an implement company that has a very, very expensive satellite-driven internet service, because he needs it for his business. He's got subsidiaries in it. So he took that and he ran a drop over to the library and hooked it up so that the kids at the high school who have dial-up service at the high school and no service at home could come in, and they could reserve an hour a night to do their homework online during, before COVID. And after COVID, You went by a McDonald's, you went by a Starbucks. Their parking lots in these rural areas are full of kids who are sitting there using their internet to do their homework because it was the only way they could get, hooked up to the internet. Farmers these days, I work on a small farm, but the big farmers around me, I had a cousin who told me the other day that he couldn't plant his seeds because he had used his, you have a planter which puts in your fertilizer. But instead of blanketing it like they used to, it puts fertilizer into a spot about that big. And then that planter remembers this. It's all driven with internet and uplinks and everything. That remembers where that's at. And so when he goes back on there and starts, it puts the seed right back where the fertilizer was. So you don't fertilize the whole feed, but it's putting the seed right back where the fertilizer was. And his planter broke. I said, well, just borrow the neighbor's. Can't, because it remembered all that. So the farmers have a huge need for this. The students have a huge need for this. The small hospitals and this type of thing have a huge need for it. So if anything, COVID was a huge, huge boost to people's way of thinking about internet and broadband and the services that we provide, to where it is almost a must-have as opposed to being a luxury. And I can tell you right now, guys, that I think it's all guys. Yeah, you guys, it's the labor needs in our industry, whether it's in operations like you're in and maintenance, that type of thing, or whether it's in the installation or the construction of it, you can't get enough. States are starting to go to schools and give them huge amounts of money to train people in broadband, the same training you're going to get here for nothing, but to produce the same types of things that they have for electric, the same types of things they have for plumbing and that, to do that for broadband, just because there is such there's such a lack of trained folks that are out there, to do this work, and it's going to get worse. I'm going to talk about funding here at the end of the session. When you see the billions and billions and billions of dollars that the federal government's putting out there, not just to build broadband, but to make sure that if it's there, people have the equipment to use it and they have the education to use it. In the next 5 to 10 years, our industry is just going to go through the roof. Our industry, but first broadband in general, that creates huge opportunities for people who are in it now or people who are getting into it now, because you're going to be at a level where you understand it and there are going to be masses of people coming in. And as I said, you kind of make the decision, do you go management or do you stay engineering? In the old days, I always make the joke that, if you could turn a screwdriver with both hands, you stayed engineering. If you couldn't, you went to management because you couldn't do the job. I was in a construction company, and it's just kind of you kind of pick. Sometimes your path is picked for you. We would hire people. We'd send them to our school. The first thing we did was train them how to climb. And anybody who couldn't climb in 5 days got transferred to underground school. So that's how you became an underground construction guy. It's because you couldn't climb poles, and that. So with more and more fiber, and like I said, you guys aren't into fiber, and it's probably pretty foreign to you at this point. But the more of it that's out there, and as they make these changes to the system, and that, one other thing to remember is the fiber and the coax are constants. Once you put it in, that's the huge amount of labor it costs to put that cable in. But once it's there, everything you do after that is all equipment. If you want to do something different on your system, if you want to offer some new service, if you want to expand your bandwidth, if you want to cut down your number of nodes, whatever that is, all you're doing now is switching equipment. Once your pipeline is in, that thing is gold, and it just works forever. And that's kind of the beauty of fiber, and that, like I said, bandwidth wise, speed wise, dependability wise, it is the way of the future. Now, unfortunately, you could throw up a wireless tower and you don't have to put in all the poles and all the construction, all the permits and everything, and you can get an internet service, but it will never grow to where fiber and to where the internet's going to go. Where we are at right now is the industry that's going to take it. Is the cable companies, the power companies in the rural areas that are putting in fiber, the people who are putting in the fiber are the ones that are going to grow and are going to be, be able to meet the challenges of what's coming. So federal government started giving a lot of money to construction companies and providers to make sure that everybody had fiber ability or had internet capability, and they define how much that is. So you can have unserved areas that have no internet whatsoever, and it is amazing how many millions of people in the country right now have no connection to the internet at all. And then they have what's called underserved, which is where you've got service, but it is like a dial-up service or such a low service, a low-level service that it is slow. You can't do the movies, you can't do the interactive type stuff. It is just too slow. So the government, back when Obama became president, had what was called the shovel-ready projects. And shovel-ready meant that if you could bring them projects that were ready to go, it wasn't years out, but it was now, you get funding. And one of the shovel-ready projects was broadband deployment in a lot of areas. And so they started throwing money out there, and I mean billions of dollars. So there is a funding source out there called RUS. RUS built the rural telephone systems, and RUS built the rural electric systems, and it's called rural utility services. And they put a lot of money into RUS. The funny thing about RUS is that all the money in RUS, this was the first funding that came out for this type of thing. All the money in RUS is part of the Farm Bill. It's not part of the FCC. It's not part of any organization that has anything to do with technology. It's in the Farm Bill. And the Department of Agriculture are the ones who oversee it. Now, you talk about the ability there to have problems. I've worked on RUS projects where we go from town to town and we use federal money to build a town, and we don't serve any of the farmers in between, which is what they were supposed to be doing. And in that town, there might be one or two operators already that spent their own money to do this. And as we go through funding sources, we start down here. So you got broadband, that's 2.65. You got rural RDOT, they call it 20. You got the rescue plan, 23. You got this BEAD is the one that everybody's after now. It's $42 billion that the government's putting out there, and none of it's been given out yet. And it is supposedly going to wire every home in America. There's no way that it will. It's not enough money. But a lot of these projects, what people did was they used it to go in to where there was already services there and build over top of it. And you're building over top of people who put their own money in, or they gave the money. They had an auction one time, and the FCC had an auction, and they auctioned off these huge chunks of the country. Said, well, how much do you need to build this? How much do you need to build this? How much do you need to build this? And all of these people came out of the woodwork, said, oh, I'm going to do, I'll take this one. I'll take this one. Give me, $250 million. Give me $400 million. There was a company in Illinois that was a wireless company that they won something like, they were the second largest winner of one of these auctions, $700 million. They had 5 employees, and Channel 5 interviewed them. They said, how are you going to do this? And they said, well, we're going to hire a lot of engineers. There are no engineers on the market these days. I mean, everybody that's worth their salt in this industry is working. Nobody's out of work these days. So a lot of this money got misused. The nice thing about BEAD is, the top one, is it's actually $65 billion. So when you think about people using the internet, and this has to do with St. Louis as much as any place else, probably in some cases more, there is not just places where the internet's not available, but there's tremendous pockets in these, especially in the cities, where people can't afford the computer, can't afford, and they have no way to learn how to use it. So out of that 65 billion, 42.6 is to build it. The other 23 billion is for services that where they will supply computers, they will pay to get it wired. They will have programs at the libraries and at the schools that are free that are going to teach people how to use the internet. I mean, I have a wife that just started carrying a flip phone. And Dennis said it's going to be on YouTube, so she will never watch this one. But and I finally got her a phone that has texting and that on it. And she carries it. She tells people she carries her cell phone for emergencies. So it's turned off until she needs it. She turns it on. If she needs me, she dials me. She says, Dick, give me a call. And she turns it off. So it does nothing. But, and she is the perfect example, at a higher demographic. But when you get down into, the cities or the rural areas where people either haven't been exposed to it or they've never been able to afford it, it's been left out. That's where there is a huge untapped market. And those people really got left behind during COVID. They were lost. When all this stuff started coming down and you had to do everything on the internet, there are huge, huge pockets of people that were just never used it, never thought they would ever need it. And then all of a sudden it's the only way you can operate, in your life. So, again, this is kind of the career push. This industry has always been a great place to work. I've been in 52 years. If you look around, a lot of the people that work here at Charter have been here, managers and that, they've been here for a long time, but they all started out at the bottom. There's a guy, I don't know how many of you, if you've never met him, but you probably will hear him. His name's Kai Nichols. He's one of the managers here at Charter. Kai and he's the president of our SCTE chapter. And he's, I think he's over construction. But his dad and I worked together in 1972. He was my first manager that I worked for. So things, the families stay in this. You get a tremendous amount of camaraderie with the people you work with. I said, you got to get along, you got to work hard, you got to pull your weight. They'll teach you everything else. This is easy. This is not rocket science. It's easy to learn. And the other thing is you see opportunities, you got to kind of go out of your way a little bit, and do a little extra effort. It can just be a job. It can be an 8 to 5 job with some overtime when you're on call and that type of thing. And it'll be a good living, but it is very easy to excel beyond that. But all it takes is just a little initiative on your part. Things like, activities, at the company, activities for the public good at the company. The one thing I tell you is I've been a member of the SCTE, the Society of Cable Television Telecommunication Engineers, for I don't know how long. I got into it back in the 70s when we came to St. Louis. We started a chapter here. We're the ones putting on this training. I suggest to everybody that's in the business that they should be in the SCTE for a couple of reasons. One of them is it gets you involved in our chapter, and it gets you with people like myself, like Dennis, like Kai, like Pete, like Steve back there. 3 of us are vendors, but the majority of the people that work on this thing, like Dennis and Kai and a number of your supervisor managers, the board of the local chapter is local. And we are part of a national group, but locally, our only purpose is training. Our only purpose is to train. And we, our chapter does probably more training than any chapter in the country. We have 1, 2, 3 different training opportunities every month. The other thing is that the SCTE has is that when you join it, and I believe that Charter employees are able to join for free. I think that the company picks up the tab for that. So it's not going to cost you anything. And what it does is it gets you on our websites, it gets you on our mailing lists, it gets you on our newsletters. It lets you know what's going on. One thing it does, and I'm happy to give my card to anybody. Have always been available to anybody. I don't care who you work for, whether it's competitors or otherwise, that any help I could ever give or references or just to talk about what people are doing. I do it all the time. That's one of the reasons I stay in this. My job doesn't require me to do a lot of work these days. I'm on a number of committees and on a number of boards from that. So it's that exposure that the company wanted I got laid off during COVID and was thinking about retirement, but I had too many people coming at me, wanting me to stay involved. And it's and I really didn't want to get out. I was on the road for 30 years. My wife doesn't want me at home all the time, because she had, every week I'm gone. So she's got her life and we get along great and everything. But if I was home 24 hours a day, 365, one of us would not be here right now, so but and I'm not saying anything wrong with that, but it's just the life that, the life that I had. But, I would suggest, like I said, to talk to your supervisors. I don't really know the, how you go about getting signed up if they have to go through their supervisor to do it first, but just request it. One thing that we don't want is we don't want just a ton of people out there who aren't involved. That doesn't do us any good. But a lot of these training sessions, as you can see, we got a lot of cameras. This is really we're really just getting into live streaming, YouTubing, but then these things would be available for you to go to and watch. If you didn't get to watch it during your work day, you could watch it afterwards. And if you know the board members and that, where the guys putting it on, we can answer any questions that you had afterwards. But the different avenues, whether it's local origination and doing their own programming in that, whether it's construction, whether it's doing the the house calls, the installs, the service calls. There's so many different avenues to go to. The other thing about it is once you're in it, there's courses you can take, there's certifications you can get. You're in the SCTE, but if you just have the knowledge and the skills, if somewhere down the line, 20 years from now, you decide, you know what, I just am ready to go where it's warm, you will never have trouble finding a job in this industry once you've got a year or two under your belt. There are opportunities out there, and basically all you need to do is, if 20 years from now, and like I said, this is a great place, where you're at right now is a great place to work. I hear very few issues with Spectrum and that. I know a lot of your management. I know a lot of your supervisors. There are guys, I get with a group every second Thursday of people that I hired when I first came to town, and they are all Spectrum employees who have retired already. And I'm thinking to myself, what is wrong with me that I'm still working? The people I hired, in the late 70s are all retired. And these were all guys climbing poles, just doing the day-to-day work and made great careers and are retiring at a relative early age, with the means to do what they want to do. Nothing to do with charter. Two things I will tell you is that 401ks, pay into 401ks every dollar you can afford. I'm sure that charter probably matches part of that deposit. That's free money. You put 2% in and they give you 2% on top of it. That's 2% raise right there. I don't know what charter does, but even if you don't, I could retire today, and the only reason is when 401ks first came out, I put in the maximum I could every month ever since then. And I've got a comfortable investment there that I can use, to live for the rest of my life if I wanted to use it. But, so whatever you can do, young people think they got time. But the thing about the 401ks, the earlier you put it in, the more money it's going to make. And it's amazing to think that you could put in a little bit of money every month and end up at the end of your career with, $1 million, $2 million in your retirement plan. That's not pipe dreams, and it's not Vegas type gambling. It's a given, that it's there. And and then the only other thing I was going to say is that I see that knowing that you're new employees and that a lot of young people, don't worry about health insurance and that type of thing. And I've got a son who plays Gaelic football here in St. Louis. These are lawyers and doctors and things out there beating their heads together every week out on a field. He's 35 years old because he thinks he's invincible. None of us are. Old people know they're not invincible, because we go through things every day. But young people as well, make sure it's and the other thing is take care of your families. This is a great industry, but it can, if you're not careful, become overwhelming and all encompassing to where you're spending so much time at it that you forget about your family. So, your family's your health. and your financial retirement are all three things to kind of look out for. But to get back to the SCTE, just kind of the way it's made up, there's the national SCTE. When we first started cable television, I mean, when you go to put an F connector on a cable now, it slides on like clockwork. It's perfect. And that's because there's a standard on that cable about what size it is, and there's a standard on that F connector about what size it is. So anybody that makes it, that adheres to that standard, they publish that, and Charter buys it. If you don't adhere to the standard, you don't. In the old days, there were standards, but the standards were, so it is, a quarter inch plus or minus 2%. And so, and on the connector side, it would be like a quarter inch plus or minus 2%. Well, if this guy's at the high side of the 2% and this guy's at the low side of the 2%, they didn't work, and that was all across the industry. So the national office of the SCTE created standards groups, and they went from everything from the clip that holds the cable onto the side of the house to the lasers that they use to produce the light for the fiber optics. And this thing, I served on this. I tell you what, it is the best cure for insomnia to sit in an 8-hour meeting talking about an F connector. Because you wouldn't think that there's not much there to talk about, but by God, there is. They would find things about millimeters and lengths but they have picked this stuff apart to where these days everything works. But the SCTE is now the nationally recognized, worldwide recognized standards committee producing for cable. The other thing that the SCTE National does is they produce a lot of educational material in addition to what we do locally. And if you join the SCTE, and again, I would not be in this industry or not be where I'm at today if it wasn't for the SCTE. And it's not as much for their training and all that, and as it is for the relationships that you're going to build. We have our meetings. We have cable games, which are vendor days, which I think Dennis talked about. Vendor day is like going to a national exhibit show. All our vendors are there. They've got displays out. They talk to you about all the different equipment that's out there. But there's just a tremendous amount of information. There's a tremendous amount of camaraderie. There's a tremendous amount of folks here locally that are here to help you with whatever you need in addition to what you're getting, at Spectrum. Most of these people are at Spectrum. Trying to wrap this, trying to think of what else. The competition, really, you don't have that much competition, as you're going to see. Competition to you guys are things like DirecTV and Dish Network and there are overbuilders. There's a company called i3 Broadband, I think out in St. Charles, that's starting to overbuild. It's the thing about people that are overbuilding is, there's barely enough. It takes all you can do financially, planning in that to make a living at cable TV. When you get into this, 3, 4, 5 years down the road, it's going to amaze you the cost of doing business in this marketplace. Programming is the biggest part of it on the video side. Programming can run 40 to 50% of your expenses can be all programming. I mean, if ESPN, I don't know the exact number, but for instance, ESPN can cost you, $7, $8, $9. Every customer is paying $7 or $8, $9 for ESPN, and it's not, it's not just because it's not just one ESPN. It's like, I don't know. I mean, ESPN's are now 26, something like that. ESPN college, ESPN kindergarten, ESPN fourth grade. There's all these different ESPNs that are out there that that you have to take. But and that's all great. But the cost. You're renting your poles. You got your fees. You got your fuel. You got your trucks. One thing I would tell you about Spectrum is, you're working for a company that is, I'm talking for the people in here, there's some Madison people out, you're the same way. And this. you will never lack for good equipment. And this is important, not just because it's nice to drive a really nice truck and nice to have a really nice ladder net. There's a huge safety issue on this thing. When, this is not, I shouldn't say it's not, this can be a dangerous industry if you don't pay attention, if you don't learn, and you don't pay attention to the rules. You're working around power, you're working in houses, there are opportunities for accidents and that type of thing. But you're going to be taught the right way to do things, do it that way. And you're going to be taught, the things to watch for and the things not to do. And as long as you do that, you'll be safe. We've got a program coming up. It's an excellent program. As many people as can should go to it. It's called Livewire, where a guy sets up in a room, not bigger than this, but he sets up a power system. So he's got a transformer, he's got a short pole, but he's got, tens of thousands of volts on this system. He's got to have this big guard going around, and he'll show you all the different things that can happen with power, not just with your work, but at home as well. It's one point he makes is, a lot of people, at work, they used to, you used to get a cut in your power cord, so you'd get a new one. Well, the guy tape it up and take it home. Well, it's bad enough that your workers are working with deficient equipment. Now you got your wife plugging in, her, whatever she plugs in an extension cord into a faulty extension cord. There's a lot of life skills that are taught with that and everything. And if you have the opportunity, you should probably try to get to that. But again, you're in a great industry. I don't think there's a better one out there. Not just because I've been in it 52 years. Because it's nothing like the one I got into. It's not nearly as interesting because you don't have nearly as many things that you have to work out yourself. A lot of it's going to be there for you. But again, if you go the extra mile, if you go the extra 10 feet and put in a little bit of extra, not just learning what you're doing, but ask why you're doing it. Or if you see something that you don't understand, in a year, you'll know everything that's in this room. You'll know how it works and how to work with it and everything. You learn a lot very quickly in cable. And part of that is because of the need for the labor market. We need you to be progressing, and we don't need everybody to become chief engineers, or we don't need everybody to become managers and supervisors. We need a lot of people out there doing what they do every day, doing it very well, and doing it with a conscious effort to be as perfect as you can. And it's not just to please the customer, but just keep in mind that any shortcut you take in the field, somebody else someday is going to have to come out and fix it. It might be you, it might not, but I can tell you chances are it's going to be Christmas Eve at 1 o'clock in the morning, because that's when that kind of stuff always goes wrong. It never goes wrong on a nice spring afternoon. Everything crashes middle of the night during the winter. And and that's about all I've got. Challenges ahead, like I said, it's going to be keeping up with the technology, but as much as anything else, it's going to be just doing a good job. And like I said, I tell people, my parents taught me common sense and get along with people. And that's the secret to my success is I use common sense. I get along with people. Everything else, it's easy. They'll teach it to you. And there are tons of people that answer your questions in that. And you're going to see different forks in the road that you can take. I took a fork in the road one time and started my own company for 5 years. Eventually it got to where I sold it, but it was a mistake. But in that 5 years, I was working with defense contractors. I wired every apartment or every dorm room at West Point Military Academy. I put the wiring in for it, and I wired a video system on the St. Lawrence Seaway all the way across it from lock and dam to lock and dam one winter. That was a real joy, upstate New York. But I worked at the Kennedy Space Center. I worked at arsenals. I worked in auto plants, and here I am. I was probably 13, 14, 15 years into my career, but you get an opportunity and you take it and you go with it. And if it's a mistake, one thing about it is if it's a mistake, you always got places to fall back on, and the other thing is we always say, once you're into this thing and once you're committed after 2 or 3 years, you can't leave. And it's not because anybody's keeping you. It's because you don't want to. You develop relationships. But the other thing is, it is one of the few industries that is new technology progresses as fast as it does in this industry, and it's going to continue doing that just to meet the needs of all the things that are coming down. When you talk about the internet, I saw something the other day that just blew my mind, that they're talking about putting in these super data centers around the country, that everything's going to, consolidate in and out, just like it's like a huge big head end or a huge big computer room. But they said that the power consumption of one of these places is equal to a nuclear power plant. One data center is equal to the power consumption put out by a nuclear power plant. And that just boggled my mind. But it's it is a great industry. It's always been a fun industry. It is now probably the most recognized industry, the most talked about industry in Washington, D.C., in any of the financial circuits and that. We are in the spotlight right now, and it will continue that way. And when I say we, I'm talking about broadband in general, which is, everybody that's out there doing it. But companies like Charter and Comcast and Madison and the people that have been doing it for years, they're in the catbird seat, because I'll tell you, they've got the people, they know how it works, they got the business model, they got the customer service set up. You are in the place to be if you want to be successful and want to have a good time doing what you're doing. So any questions? Like I said, that's kind of, again, this is not a really organized, when I give these talks, usually I have a blackboard and we just kind of go where the people take it. This time I needed to have something a little more professional for the cameras, I've got cards. I'm always available to anybody, whoever has any questions about this, or, if you have questions, ask your supervisor in that. If you have questions about the SCTE, that type of thing, Dennis or myself, like I said, I'll give out my cards, and you're welcome to call me anytime on the cell. But it is, you are in exactly the right place at, I thought it was the right time 5 years ago. It is the right time right now, because everything is going to revolve around what we do, and every job out there is important. I said a while ago, when you talk about the number of people in the cable customer service space, there is probably 60% of the people have had one interaction with cable TV, and that is the installer that came to their house. And a lot of times that's a contractor. So the only person-to-person contact they've ever had is a contractor or the installer. So no job is unimportant in this business, because the guy that puts that install in, if he does it right or if he does it wrong, he's kind of setting the tone for what's going to go on at that house for the next 10 years. If you do it right, no problems. If you do it wrong, people are going to be out there trying to fix issues and trying to find issues, every time that something comes up. So, but otherwise, guys, that's kind of it. It's, like I said, just a 35,000-foot view. I'm sure that as you get more training, and 6 months from now, you're going to remember something that was talked about here. And that's what I try to do. I try to give you a very, very rough overview of just kind of how the whole thing works in general. So as they start teaching you the piece parts and all the details and everything, you kind of see where it falls into place. So nothing else. Thank you.
I want to thank everybody on the live stream for being a part of this today and working through the bugs with us. Appreciate your patience. All the guys from Charter and Spectrum that are here in person, appreciate you taking the time out of your day to join us. Big thanks to Dick Beard of Wesco for sharing his 52 years of knowledge of the industry with us. And also would like to thank Vanna White, Pete Collier back here for facilitating the white cards.
We owe fortune 6:30.
She's got to be retiring soon, Pete. I'm sure there's going to be a job for you. So appreciate everybody for taking the time out of their day to be with us, and thanks for coming. So see you next time.